Hello everyone, in this video we're going to see the solution for the Codechef problem, squared subsequence, which is a part of April Challenge 2020 Division 2. So in this question we're given a sequence of integers, and a sequence of integers is good if the product of its element can be represented as a difference of square of two integers. And so the question is that we're given an array and we have to find the subarray, the total number of subarray or subsequence, such that their product can be represented as the difference of squares of two integers. So this is one question that is really interesting, and it took me a lot of time and a lot of TLE to get to the final answer. So I'll explain to you my approach, and I'll give a link to my code also in case you want to look at it. So let's get started. So question is, now the main thing that you should know, that if, or say if n is odd or n is divisible by 4, only then n can be represented as difference of square of two numbers. So that basically boils down our problem, and there's a whole proof of this. You can see it on Geeks for Geeks if you want to, but you should know this: if n is odd or if n is divisible by 4, only then n can be represented as difference or square of two numbers. So that boils down our question to finding the subarray such that the product is either odd or divisible by 4. Let me write that fully. Or divisible by 4. So I've done this in two parts. First, the count of subarray product is odd, where product is odd, and then count of subarray where product is divisible by 4, and then the sum of this will give me the final answer. So we have to count the number of subarrays where the product is odd, and we have to count the number of subarrays where the product is divisible by 4. So the first part is quite easy. So let's take an example. Suppose I have 1, I have 2, I have 3, or I have 1, 4, 5, 9, 6, 7, 9, 11. Now this is my, let's remove the comma because this is an array. So this is my array, and I have to find the number of subarray such that the product is odd. So what you can do is that you can simply follow the Cardinal's algorithm, and so you can traverse the whole array, and what you can do is, I'll just write the pseudocode. If a of I is odd, then odd plus plus. Odd is a counter initialized to 0, and if a of I is even, or let's just say else. Now how is this happening? So if a of I is odd, then odd plus plus. So I came to 1, 1 is odd, so odd plus plus, odd is now 1. Now then I came to 4, so my odd subsequence is finished, and so the sum will be odd sum plus odd into odd plus 1 by 2. Now how is that working? So I came to 1 and then I found 4. So right now 1 is my only subarray which is fully odd, because any subarray in which product is odd, every element has to be odd. So 1 is odd, and then the different number of subarrays I can make with 1, that is odd into odd plus 1 by 2, and I think I should write this down. For n numbers, n number of elements, total subarray possible is equal to n into n plus 1 by 2. So that is what I'm doing. The number of odd numbers I have is odd, that is the counter. So sum will be sum plus odd into odd plus 1 by 2. So right now I had 1, and 1 is the total number of odd I have, so odd into odd plus 1 by 2. Then again I initialize, or then again I make odd as 0. So 4 I don't need because I only have to take the subarray which is odd. Then again I got 5, so odd plus plus. Again I got 9, so odd plus plus. So now I have this subarray which is fully odd. Now I move to 6. When I move to 6, odd is initialized to 0, which means that I only have this subarray. So I only have these two elements which are odd, and then the total number of subarray of this subarray, that will be 2 into 3 by 2, that is 3, which is 5, 9 and 5, 9, having the product 45. Then again odd is 0, then 6 even, do nothing. 7 again we found odd plus plus. 9 again we found odd plus plus. 11 again we found odd plus plus. Now we have, in the end also you should do this even after you've gotten the loop. So sum is equal to sum plus, or let's just copy this, sum is equal to sum plus odd into odd plus 1 by 2. So finally odd is 3, meaning that this is the last subarray that I have, that last subarray that I had with all the elements as odd. So the number of subarrays I can make with this subarray, that is odd into odd plus 1 by 2. So 3 into 4 by 2, which is 6. And how is that? I can take 7, I can take 9, I can take 11, I can take 7 and 9, I can take 9 and 11, and I can take 7, 9 and 11. So 3 plus 2 plus 1, 6. So this is pretty much the code for finding the total number of subarrays which is odd. So sum is now count of subarray with odd product. So this is not that hard, this is quite simple. But for counting the number of subarrays with their product divisible by 4, this took me a lot of time. So for this, let's take another example. Suppose I take here, suppose I take 1, I take 4, I take 6, I take 7, I take 1, I take 2, I take 8. So this is my array, suppose. Now, if a subarray has to have the product divisible by 4, then it should either have 4 in it, or it should have any number or any factor which is divisible by 4. So for this, what I'm going to do is I'm going to fix all the numbers which are 4 and all the numbers which make 4, or let me have another, yeah, this example is fine. So I'll fix the numbers, say in the array, fix the numbers divisible by 4, and then every 2 consecutive even, then fix every 2 consecutive even. I know that doesn't make a lot of sense, but I'll explain it to you. So suppose this is the array. Let's just give some space in it. Yeah. So this is the array. So 4 is divisible by 4. So all the subarrays, including 4, will be divisible by 4. Right. So all the subarrays including 4. Likewise, 8 is divisible by 4. So all the subarrays including 8 will be divisible by 4, meaning that all the subarrays which have 8 in them, like this or this or this or this or this or this, all the subarrays which have 8 will be divisible by 4. Likewise, from 4, this subarray will be divisible by 4, or this subarray will be divisible by 4, this subarray, this. All the subarray which has a number divisible by 4 in them will obviously be divisible by 4. The whole product will be divisible by 4. Now, I also said that fix every two consecutive even. Why? Even which is not divisible by 4. I forgot that. So the numbers which are divisible by 4 are 4 and 8. Now, any two even numbers which are not divisible by 4, the product of those will be divisible by 4, right? Because suppose I take 2 and I take 6. So 2 is not divisible by 4, 6 is not divisible by 4, but 2 into 6 will be divisible by 4, because the first number will be divisible by 2, the second number will be divisible by 2, and the product of both those numbers will be divisible by 4. So taking this very example, I have 4, so all the subarray including 4, I have 8, all the subarray including 8. Now the even numbers which are not divisible by 4 is 6, next even number, as I said, consecutive, which is not divisible by 4 is 2. So you can think of this as another number divisible by 4. So 8 is one number divisible by 4, 4 is one number divisible by 4, and then this whole is another number divisible by 4. So any subarray including 8 will be divisible by 4, any subarray including 4 will be divisible by 4, and any subarray including this will be divisible by 4. And for that, what I've done, I'll directly show you my code for that. So this is for the odd part just shown, you can look at it, and for the even part, here's what I've done. So what I've done is, if any number is divisible by 4, then the total number of subarrays including it will be the numbers on its left plus 1 into the numbers on its right plus 1. Or I'll show you with this example only. 1, 4, 6, 7, 1, 2, 8. Let's have more space. So I'm traversing through the array. I got 4, which is divisible by 4. Then the total number of subarray will be the number on the left. The total number of subarray including this will be the number of elements on its left, which is 1 plus 1, 2 into the number of elements on its right, which is 1, 2, 3, 4, 5 plus 1, 6. So for any element which is divisible by 4, subarray, total number of subarrays including it will be the number on left plus 1 into the number of elements on right plus 1. Now if I find any number which is not divisible by 4 and is even, then I have one pointer fixed here. Then again, if I find another number, then I fix another pointer here, and then this is another, I can say, segment, and all the subarrays including this segment will be divisible by 4. So for this segment, the same thing, the number of element on left till the last 4, so which is 0 plus 1 into the number of elements on the right, which is 1 plus 2, so 2 into 1. Then this is my last array which I had fixed. Now again I found one element which is divisible by 4, so the total number on the left till the last 4, so 0 plus 1, so 1 into the total number of subarrays on the right, the total number of elements on the right, 0 plus 1, so 1. So that's pretty much what I've done in my code. If it's divisible by 4, then simply sum1 is equal to sum1 plus I minus last, which is the number on the left, into n minus I, the number on the right plus 1, the number into left plus 1. Then last is equal to I, meaning that this is the last number I had found 4. So for another either element or segment, till here I have to count the number of elements. And if I find any number which is even, then I have a flag called even. So if even is 0, so I found my first number. So I came here, even is 0, so I found my first number. Again I found another number which is even but not divisible by 4, so even is now 1, and this is 1, segment. So that is pretty much the idea. You can have different approaches to it, or you can have different idea for finding the number of subarrays having product as odd or having product divisible by 4. But to summarize, this is how you find the subarray product as odd, and for subarrays with product divisible by 4, simply what I'm doing is, if I'm encountering a number which is divisible by 4, then the number of elements on its left till the last 4 I found plus 1 into all the numbers on its right plus 1, multiply them. Then again, if you found one even number, then look for another even number which is not divisible by 4 consecutively. So if I found 2, then again I have one segment which is divisible by 4. So for this segment, the total number of elements on the left plus 1 into total number of elements on the right plus 1, multiply them. But do remember to make sure that we don't have any overlapping arrays. I'll explain that again. So if I have 4 and if I have 1, 3, 5, 6, 5, 2, if I have this, so I found 4 divisible by 4. So the total number of elements on the left, 1 plus 1, 2 into the number of right, 1, 2, 3, 4, 5, 6, 7 plus 1, 8. So 8 into 2, 16. Now again I found 6 and 2. So this is one segment divisible by 4. So let's have 7 also. So this is one segment divisible by 4. So the total number of elements on the left. Now when I say the total number of elements on the left till the last 4, so these 3 elements plus 1, 4 into the total number of elements on the right 7, the total number of elements on the right 1 plus 1, 2, and the product of that. So if you either found a single element which is divisible by 4, or if you found a subsegment, or if you found a segment which is divisible by 4, then find all the subarrays including either that element or that segment, and make sure that there are no overlapping subarrays. And I'll also give a link to my code. If you have any doubts, just post it in the comments. I'll be sure to answer. Thank you.